Okay, we have used the math module, and we've talked about using the import keyword to import a module into your current code. In this section, we're going to take a look at how to create modules of your own. First of all, we need to know what variables exist in your running environment, in your shell in our case. So one function you can use to find out which variables currently exist in your shell is the vars variable. And what this will produce is a dictionary in which the keys of the dictionary are the names of the variables, and the values in the dictionary are the values of those corresponding variables. All right, so here we have our first key value pair in this dictionary that's displayed. The name of the variable is underscore underscore name underscore underscore, and the value of that variable is underscore underscore main underscore underscore. Then we have a variable called underscore underscore doc underscore underscore, which is set to none, and then package and loader and spec and annotations and a bunch of other things. Here we have some variables that I created myself: stir4, referring to a string; list1, referring to a list of integer values 0 through 9; t1, which is a tuple of one-character strings; and set1, which is a set of one-character strings. So that's what I currently have as variables in my shell. The shell created several of these for itself, and then I came along and created several other ones after the shell started running. Now, since the vars function returns a dictionary, we can do a subscript into the dictionary looking for a variable name. We need to remember to type the variable name in quotes, because within the vars dictionary, the variable name is stored as a stir, as a string, containing quotes. So here is the value of the variable underscore underscore name underscore underscore, and as we see, it's underscore underscore main underscore underscore. Now, I'm going to get tired real quick of saying underscore underscore all the time, and you're going to get sick of hearing me say it. So let me just mention that in Python land, these variables and values whose names start with double underscores are typically called dunder variables. Or if you have a function whose name starts with an underscore, with two underscores, dunder is short for double underscore. So a Python person will describe this variable whose name is underscore underscore name underscore underscore as dunder name. And as we're seeing here, the value of dunder name is dunder main. So the main module is whatever code you are currently interacting with. In the case of the shell, of course, it's the shell itself that you are currently interacting with, and the shell always thinks of itself as the main module, the primary module. It will always have a variable dunder name set up, and that variable in the shell will be dunder main. If you're editing a file, on the other hand, and you execute that file, you're editing a file containing Python code, a file whose name ends in .py, and you execute that file or run that file, then that file, when it starts running, will think of itself as the main module. Okay, so here we have a code file whose name is prog2.py. And what this code file has in it is our function definition for computing the Fahrenheit to Celsius conversion. We pass in some Fahrenheit temperature as the argument, and the function computes the corresponding Celsius temperature and then returns that Celsius temperature back to wherever the function was called. So there's our function definition. Then we have a print statement here that's displaying 80, and then the string f is, and then the value returned from f to c of 80, and then the string c. We're also in this program, using a print statement to display this module's name is, and then dunder name. If I run this file directly by saying run module, or pressing F5, here's the output that I get. The first print statement displays 80F is 26.6668 C. Right? So 80 degrees Fahrenheit is approximately 26.666 Celsius. And because I am running this file, when I get down here to where the dunder name variable name is used, its value is dunder main. Okay. Now, we might import this program that we just wrote, prog2.py, into another program so that that other program can make use of the f to c function that we have defined. All right, so here I have another program. Let's see, here's my prog2.py program file. It has a function definition in it, and it also has two print statements in it. Here I have the prog3.py program, separate file, and what it does is to import prog2 with the abbreviated name P2. So now, within prog3, I can execute prog2's f to c function using this notation p2.f to c. All right, so I give the module name, or in this case the module abbreviation, and a dot, and then the name of the function that I want to invoke from that module. And we should discover when we run prog3, 32 Fahrenheit should be 0 Celsius, 212 Fahrenheit should be 100 Celsius, and then 76 will be a little bit less than what we got for 80 here. So it'll be a little bit less than 26.666. All right, let's try this. I'll hit F5, or run module. I'll press F5. Interesting. So I did get told 32 Fahrenheit is 0 Celsius, 212 is 100 Celsius, 76 is 24.444, whereas 80 was 26.666. And I got told this program is main, all right, because the last print statement in prog3 has this program is and then dunder name. However, I also got these two lines of output. What's that about? Well, when you import a program into a module, when you import a file containing some Python code into another program, what that does is pull in and then execute an entire copy of that file. So what's happening here in prog3 is that an entire copy of prog2 is being pulled in where this import statement is, and then being executed. And if we look back at prog2, what we had in prog2 was not just the definition of the f to c function, but also there were these two print statements displaying that 80 Fahrenheit is 26.6666C, and also displaying this module's name is, and then whatever the value of dunder name is. In the output, you'll notice, oops, come here, here's the output. In the output, you'll notice that the first print statement from prog2 displays what it displayed before. 80 Fahrenheit is 26.666, etc. C. But the second print statement, okay, this print statement here, instead of displaying dunder main, displays prog2. Okay, so when a module is imported, in this case prog2 is being imported into prog3, that module does have an internal name, that is an internal value for dunder name, but the value is the name of the module file with the .py extension removed, not dunder main. In this case, since the name of the file is prog2.py, the name of the module, when it's been imported, is just prog2 with the .py extension taken off. Now, we don't really want to see, when we make use of the F to C function contained within the prog2 module, we don't really want to see these other two lines displayed. We really want to just use the F to C function within our current program, prog3. So let's make a couple of revisions to prog2 and also to prog3 to prevent these extra couple of print statements within prog2 from being executed. All right, so instead of just plain old prog2, we're going to use this new and improved version called prog2a.py. And this time, what we've done is we've used this if statement. Whoops, too far. I hit too many. I hit too many page downs. All right. So here's our original prog3 importing our original prog2, and the output that we got had the two print statements from prog2.py as well as the four print statements from prog3.py. Now, to hide the other output, that is to hide the two print statements within prog2 from being called or executed automatically when the import is done, we'll use an if decision to test the value of the dunder name variable. All right, so here is our new and improved prog2a. Let me show prog2, and we'll put prog2a right underneath it. Pretty sure I can get them both to be displayed. Yeah, there we go. All right. So prog2 has the definition of the F to C function, and then it has two print statements. And these are all just executed in sequence when prog2 is imported. Prog2a has the same definition for the F to C function, but notice that instead of just having these two print function calls, we're saying if dunder name is dunder main, then and only then execute these two print statements. So if I execute prog2a itself, if prog2a is my current module, and I run prog2a, I get those two print statements invoked because dunder name is dunder main in this case. However, in my prog3a program, which is going to import prog2a, and in fact, that's the one and only difference between the original prog3 and prog3a, is that prog3a is importing prog2a. When I run this program as my main module, I won't get any output for the two print statements contained within prog2a. Whoops, it's not the one I wanted. Here we go. Okay, here's prog3a. It's importing prog2a, and prog2a has this if statement that detects if dunder name is not equal to main, we're not going to perform these two print statements. And that's the case here, because when we import prog2a as p2, the name of the module internally within prog2a.py is going to be just the module name without the .py extension, so it'll just be prog2a. And so we only get the 4 print statements from prog3a. All right, so here is our new and improved version of prog2a. If we run prog2a as the main module, it still prints the same information it displayed before. But now if we run prog3a, we only get the output contained within prog3a, not the output from prog2a. Okay, so that's our first look at defining modules. And the main things to get here are that if you want to make functions available from the module that you're defining, those should be outside of this if dunder name equals dunder main logic. Any test functions that you want to call within the module itself to test the behavior of, in this case, the f to c function, those should be hidden within this if statement so that they are executed if and only if this is the main module that's currently being executed, not a subsidiary module that's being imported by some other module. Alrighty, so that takes care of that.